Maple TA Exam Review Unit 3, question number 14. Solve the following independent system of equations. So first of all, they told us it's independent, so we don't need to determine if they are. So I'm not going to solve these both for y, like I did in some of the previous examples when we were just trying to determine if it was independent or dependent. This one, we can do the book method, which was to use substitution, or we could do the other method that I showed in one of the videos to do elimination. And I'm going to do both just so that those of you who might want to see the elimination method, since sometimes it's a little faster. The first thing I'm going to do is pick one of these equations and solve it for either x or y, and it doesn't matter. And so I'm just going to pick the first one and solve for x just because that's what I decided. All right, so the first thing I want to do is subtract or add 8y to both sides so that it stays a balanced equation. This equal sign, add 8y. Okay, and then I have 3x, and keep my equal sign in the middle so it keeps my work neat and tidy. And in this case, because I'm not doing slope-intercept form, I can do the 8 or the 66 first. It doesn't matter, so I'm just going to do the 8. We'll do the positive one first, just because. So 8y minus 66, and then I need to continue solving for x by dividing everything by the opposite, or doing the opposite here. Since it says multiply, we need to divide every single term by 3. So divide by 3, divide this term by 3, and divide this term by 3. On the left-hand side, 3 divided by 3 is 1, so that leaves me with x. X equals, simplify this up a little bit, still 8/3 y. 66 divided by 3 is minus 22. Okay, so now that I've solved for x, I'm going to take all of that and substitute it into the other equation for x. Make sure that you use the other equation and not the original, or you'll end up with a dependent system because they're the same equation, right? So make sure you get your second one there. All right, so now every time I see this x here, I'm going to put in parentheses and substitute what I solved for x and place it in there. Now, using the distributive property, I'm going to multiply the 8 into both of those terms. 8 times 8 is 64. 64/3 y. 22 times 8 is, I'm going to hurry and do that. On my calculator, I get 176. And then minus 3y equals, whoops, I meant to put 3y, equals negative 11. Okay, now I'm going to combine my y's. I just had this thought. Those of you who don't want to work with fractions, we could get rid of them by multiplying everything by this fraction over here, and it's still the substitution method, and you don't have to work with fractions. So I'm going to do that. I'm going to teach you how to get rid of them. So right here I only have one fraction. It's a 3, and so if I multiply every single term by 3, I will eliminate the fraction here, and I think that might be helpful for some of you. So I'm going to do that. I'm going to multiply this entire thing by 3 instead of trying to find a fraction here, which I could. Multiplying the numerator and denominator here by 3 gives me minus 9/3 y, and then I can do 64 minus 9. Those of you who want to continue down that path with fractions, go ahead. You'll do 64 minus 9 y, and then you still have the minus 176, and then you'll continue by adding 176 to both sides, so you have the negative 11. Okay, and then at the end, if you want to continue down the fraction path, multiply both sides by the reciprocal. In this method, I am going to get rid of this fraction by multiplying the entire thing by 3. So every single term using the distributive property. So this first one, the 3 on the top and the 3 on the bottom cancel, or 3 divided by 3 is 1, and you're left with 64, which is nice. But now I need to multiply the 176 by 3, which gives me 528. and then 3 times 3 makes this 9, and you'll notice it was by a positive 3, so all of these signs are still the same. And then 3 times the negative 11 makes this negative 33. Maybe that'll help some of you instead of having to do some of these fractions. Okay, so now I'm going to combine the 64 and the 9 so that my y's are the same. So I end up with 55. Is that right? 4, 5, I think it's 55. Positive 55y. I still have this 528 and negative 33. Okay, so just now I need to add 528 to both sides so that the y is all by itself. So I'm going to come down here and say add 528, add 528, and then I have on the left hand side I'm left with 55y, and then 528 and negative 33 make 495. 495. And then to continue solving, I need to divide both sides by 55 so that the y is all by itself. Divide by 55. Divide by 55. And I am left with 9. So y, I should move that over so that the equal signs are lined up. Y equals 9. Well, as close as I can line them up in my my document. That's good. Okay, so now I need to solve for x. So I'm going to take the equation that I solved for x and bring it down here because that eliminates me having to solve more algebra up here. So I'm just going to substitute it into where it already is solved. And then I can type this into my calculator, or I can reduce beforehand, which is what I personally like to do. Some people might get, I hope we're okay with that. So if I have a 9 over a 1, 9 on the top and 3 on the bottom, I can simplify those by getting 9 and 3 become, or 9 divided by 3 is 3, so then I just have 3 times 8. If you're not okay with that, you can do the 9, the numerator times the numerator, which is 72, and divide that by 3. So it's up to you whichever way. So I get 24. 72 divided by 3 is 24, or the other direction, which was 3 times 8, which is also 24. So I have 24 minus 22, x equals 24 minus 22, which equals 2. And so my answer is the y, or the x value is 2, and the y is 9. All right, okay, so the elimination method, for those of you who wanted to continue and do that method, although now that I've shown how to get rid of that nasty fraction, maybe you'll rather do the substitution method and just multiply everything and get rid of the fractions. But because I said I would, I'm going to go ahead and do the elimination method as well. So I'm going to pick either getting rid of the x or the y, and it doesn't matter. But there's not really a fast way to go like to multiply this by something to make it 8 unless I'm working with fractions, and again for either of these. So I'm going to end up multiplying both equations by something so that I have the numbers the same out in the front and I can eliminate it that way. Let's get rid of the x, I guess. So right here I'm going to multiply this by 8 and this by 3, so it makes these both 24, so that they'll cancel out. So I'm going to show that I'm going to multiply this by 8, and then I'm going to pick one of these to be negative so that when I add them together, that x will go away. So then 3, there we go. Okay, so doing the distributive property, we're going to multiply those in, and I end up with 8 times 3, which is 24, 24x. Oh, and I said we need one to be negative, so let's do that one negative. And then 8 times 8 minus 64y equals 8 times 66 is 528, and that's negative. Okay, and then down here, negative 3 times 8x gives me negative 24x. And then 3 times negative 3 is positive 9y, and you'll see these numbers are pretty similar to what we had up here. And then negative 3 times negative 11 gives me positive 33. And then I'm going to add these together, the x's, the y's, and the numbers. And the reason I can do that is that this equals this, and this equals this, so I am not changing this equal sign because the value stays the same. It's like adding 7 to both sides, except in this case I'm actually adding 33 to both sides. I just don't know what the distribution is over here between the x and the y. So 24 minus 24 is 0, and so then I have negative 64. Negative 64 plus 9 gives me negative 55y, and then a positive or a negative 528 plus 33 gives me negative 495, the exact same thing we had up there. Divide both sides by 55. A negative 55 makes it both positive, and so that positive y equals a positive 9. And then again, just like we did before, we're going to substitute this into one of these equations. It doesn't matter either one, and so I'm just going to pick the first one because I picked it. And then we're going to substitute 9 right here with parentheses, making sure every time I see an x, I substitute whatever that is inside those parentheses. So then working this out, I have 3x. 9 times 8 is 72. Oops, we need to keep working, yes. And then equals negative 66. Then we need to add 72 to both sides. And then I have 3x, and positive 72 minus 72 is 0. So then I have negative 66 and positive 72, which gives me a positive equals a positive 6. And then divide both sides by 3. 3x divided by 3 is x, and 6 divided by 3 is 2, and I did that in my head right there instead of writing it out. If you are not comfortable with that, you could do divide by 3 and divide by 3 like this. All right, and so we still ended up with 2 and 9 for our solution. All right, that one's, we'll work on the next problem.